Hi everyone, I'm Goldie and I'm here to make programming concepts easy to understand. In this video, we are going to be going over procedures in the AP CSP Pseudocode. So we'll learn all about what procedures are and how they really allow us to make a more organized and efficient program. We'll talk about how to define them, how to call them, and how to use them in our program, both with and without parameters and with and without return values. So if you're ready, go ahead and buckle in and let's get into this content together. So a procedure, what we call a procedure in the pseudocode, is a piece of code that we can easily use over and over again. And it allows us to code some sort of series of statements. Sometimes it's just one statement, sometimes it's many statements, but we only have to code it once. And then we call on that code segment that we wrote as many times as we need throughout the program. So if we want that series of statements to happen a couple different times in the program, instead of coding it a couple different times in the program, we can just code it once and then call on it whenever we need it. So this just allows for a shorter program, a more organized program, and just overall a better looking program for the programmer. So the programmer can code the segments once, name it with a block of code, and then call on it anywhere in the program. A procedure is called many things in various programming languages. Each programming language has a word for it. JavaScript and Python, we call it a function. And in Java, it's called a method, and then so on and so forth. Every programming language has a form of a procedure. So we're talking about procedure. If I accidentally use the word function or if I accidentally use the word method, it all means the same thing. But the pseudocode for the AP CSP exam does call it a procedure. Now, there's a few different types of procedures we can create. The first one we're going to talk about is creating and using a procedure without parameters. So here's the pseudocode and the way it's given. There's two pieces to the procedure. First is defining the function, defining the procedure, and second is calling it. So you can see here first defining the function, we start by naming it procedure. And then we have the name with open and closed parentheses, nothing in them. And this is what we mean when we say a procedure without parameters. So inside parentheses there would be what we would call a parameter. And we'll get into that a little bit later on in this lesson. But for now, there are going to be no parameters as we're just kind of getting used to what a procedure is. So no parameters. So part of that is just open, closed parentheses. That's just part of the syntax that we use. The name is what we call the function, what we call the procedure, and what we use when we eventually want to call on it. You can see we have a block here, just like we did with our if statements. And then in here, we have just a block of statements that we want completed whenever we call on the procedure. Okay, so that could be one line or it could be multiple lines. So we define it first in our program, and then in the second space, we call it. And the way we call it is with name, whatever name we give it, and then with the open and closed parentheses. Now, if we had parameters, we would actually put values in there when we call the function, but we'll see an example of that in a little bit, okay? So when we define a procedure in pseudocode lets us define a procedure anywhere in the code segment, as you'll see. I always just define it at the bottom, but you can really define it anywhere in your series of statements, in your series of code. And some languages are very specific about where you can code a procedure. Like in Python, you can only code your functions in the beginning of the program, at the very top. And you have to define your functions at the top, otherwise your program won't run. Versus like Java, you can code your methods anywhere, and they can run anywhere, kind of like the pseudocode here. So every programming language has its differences when it comes to here. For the pseudocode, it's just straightforward. We'll just define it anywhere and call on it when we need it. So when we call on it with this name, it executes that block of statements inside that function, and then the program returns to where it was called and continues with the program. So we're going to see a simple example of it here. So notice how I have a display line. Then I have, this is a procedure call right here, example with the open close parenthesis. And what that means is you're going to go to the procedure labeled example, and you're going to run that code segment in example. Okay, so what this looks like, our first line of code, remember it goes in order from top to bottom. So the first thing that's displayed is the letter A. Then when I get to this line of code, it's a procedure call. So what the program will do is it'll say, okay, let me go to the procedure named example. So it'll go down to example and it'll run the code in example. Okay, so it kind of takes a break. It pauses here, jumps to the code in example. So it'll display C and then it'll jump back. Okay, so after that procedure has ran, all it does is display C. It'll jump back and then it'll continue on with the code segment. So the last thing is display B. Okay. So that's kind of how the flow of execution works with procedures, is when you reach a procedure call, your code pauses, it goes to that procedure, runs the code, and then comes back to where it left off. Okay, so again, we typically put these definitions at the end of the program to keep things organized. But when you get into like Python, if you're learning Python like we are, all procedures need to be written at the start of the program. So we'll go over that a little bit more when we start talking about functions in Python. But for now, you can see that I have my code segments here and then the procedure at the end. Now remember, the procedure doesn't run unless it's called on. So like here, I displayed A, C, and then B, but then I stopped. Notice how I didn't display C again. I didn't keep moving down, and anything in a procedure is not run unless it is called on. Okay, so I only called example. I only called that procedure once in my program, and that is why it only ran once right here. Okay. So here's our other example. What is displayed after the following code segment is executed? So first we have tiger. Start at the top. As we go down, then I have my call to my animal procedure. So it goes down to animal, and then what gets displayed is bear. So bear gets displayed next. That line of code ran, that procedure is over, and I go back and I continue on with my program. Next up, I display lion. Then I run into another procedure call. So I'm going to call on it again, and I'm going to run the code again. So bear gets displayed one more time. I jump back. Cheetah is the last thing to get displayed. Okay. So that's an example of a procedure without parameters. So without parameters, it's just the name and then an open and closed parenthesis. Okay. The next one, we're going to talk about creating and using a procedure with parameters. Okay. So what is a parameter? I've mentioned it. What is it? They're variables whose value is passed into a procedure. And parameters are something special that just allow us to kind of customize our procedure. A parameter is a value that can only be used within a procedure, and whatever you input as a parameter can change how the procedure behaves. And that's why we like using parameters with our procedures. You can have as many parameters as you need. You can have obviously we saw you can have no parameters, but you can have 1 parameter, 2, 3, you could have 100 technically. Each parameter is given as a variable separated by a comma and a space. Okay? And the order that the values are passed are the same as the order that they are received. So what this looks like in the pseudocode, again, with the procedures, you define the function and then you call it. So now you see we still have the word procedure, all capital to define a procedure. Then we have the name of our function. And then now inside our parentheses, we're going to have parameters. And these are just going to be variable names. And within this block of statements, we're going to do something with those variables we are passed. Okay, so it's just going to be variable names. When we call on the function, then again, we use the name of the procedure in the call, and then in parentheses, we give it values. Okay, so this value, this first value that I pass it, whatever it is going to be represented as parameter 1 in my procedure. The second value that I passed is going to be passed and be represented as parameter 2 in my procedure. So the order that I give these values in the call is the order that they are received in your procedure. So let's look at two examples of this. Okay, so first let's start off on the left here. Again, we're starting at the top. X is given the value of 10. And then my next line of code says display 10. So I'm going to display 10. And then I have mystery and then in parentheses X. So mystery is a procedure. So that means I'm going to go down to mystery. Okay. I'm going to go down to mystery. And what am I going to do? Well, it says pass it X. What is X? Well, X is currently 10, which means that I take that 10, I pass it to that procedure. So procedures are passed by value, meaning if you pass it a variable like X, that means you are passing the value of X. So X is 10, you're going to pass it to mystery. And then down in mystery, num is going to be 10. Okay, num gets the value of 10. So you pass the value of 10, num becomes 10, and then in the procedure, what happens to num? Well, num gets 3 added to it, and then gets stored back into num, so that becomes 13, and then you display num, so you display 13. And then the procedure is over. You jump back up, and you are going to finish the last line of code, which is display X. And X is actually still 10, so you display 10, and then your program is over. So you go 10, 13, and 10 with these 3 lines of code. Okay. So procedures are passed by values. Procedures do not create a relationship. There's no relationship between X and num. Okay. No relationship when you do that. This just means, hey, take the value of X, which is 10, and then pass it to num. Okay? So basically make a copy of it is what happened. Num became 10, X was 10, but there's no relationship between those values. Just because num changed doesn't mean that X changed. Okay? Let's look at another example of what this looks like. So over on the right side here, we got Y is 20, X is 4. My first line, it says display Y. So I'm going to display 20. Y is currently 20. My next one, I have function X comma Y. So again, this is passed by value. So X is currently 4 and Y is currently 20. Okay. So when I pass the function X, Y, that means I pass the values. And you pass it in the order, and it's received in the order it was passed. So X was first, it was 4, and that's why val 1 becomes 4. Y, which is 20, was passed second, and that's why val 2 is going to be 20. And I have that displayed right down here as our little trace. So you pass the value. Again, there's no relationship between val 1 and X. There's no relationship between val 2 and Y. You pass the value. And then in this procedure, we're going to do something with val 1 and val 2. We're going to subtract them. So val 1 is 4, val 2 is 20. When I subtract them, I get negative 16, and that's going to be stored in a new variable called num. And then it says I display num, so I'm going to display negative 16. And then my procedure is over. Once the procedure is over, done, I come back up to my function. It ran, life is good. So I'm going to move on to the next line of code, which is just to display X, and that is 4. That's my procedure. Now, we'll do a lot of practice with this to make sure we're comfortable. Remember that these variables, val 1 and val 2, only exist in the procedure. So if I tried to write something outside of the procedure, like display val 1, in the pseudocode, as well as most programming languages that I know, at least, you will get an error. Okay. These only exist inside the procedure. So you can only use them when they are inside that procedure. Okay. Same thing with num. Okay. Num was created inside the procedure, so it can only be used inside the procedure. That's just a feature of programming languages in general. Okay. But I do have some practice. I have 2 practice problems before we move on to the last type of procedure here. So with these 2 practice problems, if you wanted to try them on your own, you're welcome to. Otherwise, I'm going to go through the answer right now. They just include a little bit more things in them to practice with. So what is displayed after the code has executed? So I have my only 3 lines up here. Okay, 3 lines, and then I have my procedure. Okay, so when you're looking at tracing code, kind of just give it an overview and see what you're working with here. Inside my procedure now, my procedure is called do stuff, and I can see that I'm going to have a series of if statements that I'm going to be doing stuff with X. So the first line says do stuff 19. Okay, so this time I'm actually passing it a number itself, so I'm not passing a variable. So I pass it 19, which means X becomes the value of 19. And then it looks like I'm going to go through this series of if statements and do stuff when X is equal to 19. So first off, 19 mod 10 is 9. Okay, so X mod 10, which is 19 mod 10, is 9, which is greater than or equal to 5, which means that this statement inside is going to run. So the first thing that's displayed is first. And because this is if statements and not like an if else statement, that means that I'm going to move on to the next statement and run that. 19 mod 5 is 4, which is greater than or equal to 2. So I'm going to display second. 19 mod 20 is 19, which is greater than or equal to 10. So I'm going to display third. And then 19 mod 4 is 3, which is not equal to 2, so I don't display fourth. So I go through my procedure, do stuff 19. I go through all 4 of those if statements. I figure out what is displayed. I've reached the end of my procedure, which means I go back up to where this procedure was called. I go back up there and I keep running the code. So the next thing that's displayed is break. And then I do stuff again. I do stuff. Now this time X is equal to 82. So I'm going to go through the same steps, but this time X is going to be equal to 82 as I go through. Okay. So here, 82 mod 10 is 2, which is not greater than or equal to 5. So that means I don't display first. I go to the next one. 82 mod 5 is 2, which is greater than or equal to 2, so I will display second. The next one, 82 mod 20 is 2, which is not greater than or equal to 10, so I don't display third. And then 82 mod 4 is 2, which is equal to 2, so I do display fourth. So you can go through, you can double check, remember mod is the remainder, okay? So it's what's left over after you divide by that number. So like 82 mod 4, right? 4 goes into 80 evenly, okay? And then the remainder is, there's a remainder of 2, okay? Ooh, sorry. So maybe I should be more careful. 4 goes into 80 20 times, and then there's a remainder of 2. Okay, trying to do my long division. Okay, and that's what gets displayed because when I reach the end of the procedure here, I go back up and there's no more lines of code, right? There's the procedure definition, which again, it doesn't run unless it has that procedure call. Okay, here's problem number 2. I see I have my lines of code here, I have my procedure here, and inside my procedure I have an if and an else statement. This procedure does accept 2 parameters, so I'm going to be ready for that. Okay, I'm going to start off X is 5, Y is 10, and then it says mystery X, Y. Okay, so I'm going to make a call. X is currently 5, Y is currently 10, so I'm going to pass those values to num1 and num2. So num1 becomes 5, num2 becomes 10. And then when I'm working in the procedure, those are going to be the values. Okay? So num2 mod num1 means I take 10 mod 5, which is 0. Is 0 greater than or equal to 1? It is not. So that if statement, the statements inside this if, do not run because this is false. 0 is not greater than or equal to 1. My else statement runs. And inside this else statement, I take num2, which is 10. I add 20, and that becomes the new value of num2. So num2 becomes 30. And then I display num2. So that's why off to the side, I have it display 30. Okay. That's the end of my procedure. When my procedure is reached its end, I go back up to my display, and notice also how num1 and num2 disappeared off my screen. Okay, and that's because when a procedure is run, it has values from num1 and num2, but then once the procedure is done, the computer basically says, okay, we don't need to know those anymore, and throws them away. Okay, the values of x and y are always there, okay, because that's back up in your series of statements here. But for a procedure, once that procedure is done, all of the content that went with it is lost. Okay. So I display x, which is still 5. I display y, which is still 10. And now I'm going to make a mystery call to 3, 10. So 3 is num1, 10 is num2. So now num1 and num2 get new values. So you see it restarted. So now I check 10 mod 3 is 1, which is greater than or equal to 1. So that's why, because it's greater than or equal to 1 here, I'm going to run these 2 code segments, and I'm going to not run my else statement. Okay. So in this code segment, num1, which is 3, gets 4 added to it and becomes the new value of num1. So it becomes 7, and then I display that value. I display num1, so I display 7. Okay. So over in this box, I display that 7. I skipped the else. I've reached the end of my procedure, so I come back up here, and that was the last statement in my problem. So I am done now. Okay, good stuff. So that's a procedure with parameters. The last type of procedure we're going to talk about is a procedure with return values. So procedure can return values back to the original calling statement, and you can return values with or without parameters. Okay, so maybe your procedure has parameters, you can return something, maybe it doesn't, you don't have to return something. But you are able to do this by simply adding a return statement at the end of our procedure. And what that does is it returns a value, whether that's a number or a string of some kind, back to the original calling statement. And you'll want to have either a variable to capture that value that's returned, right? Or a display statement to reveal what it is. So I always think of like a baseball example, right? If you toss a ball to someone, you want them to have a glove to catch the baseball. And it's the same thing with our code. If a procedure is going to pass a value back to you, if it's going to return a value, you want a glove to pass it in the form of a variable, okay? Or a glove to catch it in the form of a variable, okay? So here's what this looks like. Again, it's all about the defining the function, calling the function. So it may or may not have parameters. In this pseudocode example, it has parameters, but you're going to have some sort of block of statements, and then you're going to have return expression. And this expression can be, it might be a value like an integer, a decimal. It could be a Boolean. It could be a string of some time. You just return it. And then what you're going to want to do, so this is the function call, then you're going to want a variable to capture whatever was returned. Okay. So whatever was returned is returned back to the place where that function was called. And then you'll want to capture it somehow, either with a variable called capture, or maybe you want to just display it. That would be fine too. But you're returning a value back to the original statement in order to do something with it. Okay. So we'll see 2 examples here, an example and then a practice problem of this. So I have my 2 code segments, and then I have my procedure here. Okay. So what's going to happen? Well, in this first line of code, I see a procedure call. This procedure call will evaluate the procedure with the values 4, 6, and 11. So 4 gets passed to x, 6 gets passed to y, 11 gets passed to z. And then whatever value is returned will be stored in answer, because I see I have a return statement in this procedure. Okay. So let's go through. So average, I do the function call first. X is 4, Y is 6, Z is 11. It says I'm going to take the sum of those three, which is 21. And then I store that in the variable sum. And then I take sum divided by 3 and store that in mean. So 21 divided by 3 is 7. And then it says I return mean. Okay. So it's a return the value, right? So I return the value of 7. So I return that value of 7 back up to my procedure call, which means that 7 is going to get stored in answer. Okay. Now that procedure is done, all the values that I used for those variables inside the procedure get erased. Okay. And then I display answer, and the answer was 7. Okay. There it is. I have one last practice problem here. More of just you kind of trace it, and then I want to know what should go here so that C gets displayed. Okay. So I display, and this is an example of having a function call inside a display. So that means I'm going to call this function, and based on these return statements, I'm going to return an expression, either A, B, or C, and that's going to get displayed here. Okay, so message 468, 4 becomes X, 6 becomes Y, 8 becomes Z. So that's what I have right here as part of my trace. And then I go through. Is X less than 6? It's true. X is 4. So X is less than 6, which means I return A. Now, fun thing, okay, once you reach a return statement in a procedure, you return that value and you are done with the procedure. So I return A to this procedure call, and then now it says display that result. So I'm going to display A. Next, I run this again. This time, X is 10, Y is 2, and Z is 2. So the first one is X less than 6. That is false. 10 is not less than 6. So this gets skipped, and I moved right into my else statement. Okay. In my else statement, I have another nested if statement. And this wants to check if Y is less than 3. Is Y currently less than 3? That's true. So I've reached this return statement, and I'm going to return B back up here to my message. Okay. And that means B is going to get displayed. And then my question, what number should go in the blank so that C gets displayed? Okay. I want to display C, which means I want to reach this return statement right here. Okay. The way that C gets displayed is if I return C back up here to this message call. So I need to know what numbers are going to get me there. Okay. Well, those numbers, this has to be false and this has to be false. Okay. If this is false, that means I skip here and I go to the else statement. And then when I'm in here, if this is false, that means I skip here and I go to this else statement. Okay. So I need to choose 3 numbers. X has to be greater than 6 and Y should be greater than 3. Okay. Because those values would give me false and false for both of them. And it actually doesn't matter what Z is in this situation. Okay. Z could be any number, and I would display C as long as X is greater than 6 and Y greater than 3. So whatever you wanted to do, I did 7, 4, and 10, but X as long as it's greater than 6, Y as long as it's greater than 3, and Z can be anything here. Okay. And then C gets displayed. We'll do a lot more practice with that so you feel more comfortable. Again, this is just the lesson to kind of introduce all of these 3 different types of procedures on the pseudocode, and just kind of let you know what's going on with them. So we'll practice a little bit more. The last thing I want to talk about in this lesson is procedural abstraction. So we've talked about abstraction before, but procedural abstraction is actually something we just did. It's a name for a process that allows a procedure to be used only knowing what it does, not necessarily how it does it. And we saw this before in another lesson with like random, when we were talking about the random procedure and how we called on random. We actually don't know how it generates a random number. We just know that it does, and that we're able to use it because we just, know it's going to give us a random number, but we don't know how it does it. And that's the beauty with procedures. So they allow us to code small solutions to a larger problem. Okay. And by doing that, we can call on these smaller procedures to help us solve a bigger problem without really knowing how those small problems are solved. Okay. This subdivision of a computer program into separate subprograms is called modularity. Okay. And just using this concept helps improve code readability and just you're able to understand the program a lot better when you read it as a programmer, okay? So using any type of procedure in your program is a huge part of procedural abstraction. And going into the CSP create performance task, procedural abstraction is a huge part of the create PT. So you're going to see that term procedural abstraction again when you're trying to fulfill the requirements of the create performance task. And just know that any of the procedures we just went over are going to help you accomplish that. And that wraps up today's lesson on procedures in the AP CSP Pseudocode. I appreciate you guys following along with me. If you did like this video, please hit the like button and subscribe to my YouTube channel for more great CS content. Until then, please keep coding, keep learning, and I will see you in the next video.